Welcome back, learners. Today we are discussing about the IT application in power distribution. And for the benefit of the learners who have joined us late, I should introduce my experts again. Mr. R.C. Dhoop is here. He is General Manager, APDRP, NTPC. And also with me I have Mr. S. Rudra, who is Deputy General Manager, APDRP, NTPC. So the discussions will be continued. I would like to request Mr. R.C. Dhoop to please continue the discussions.
Thank you, Dr. Bhargav. Now we were at the concept, what is a integrated IT platform for the distribution utilities. So we have just now talked about the customer care centers, how at the back end it gets integrated, and the total information about a customer is available and it's only a mouse click away. That is the kind of a customer care center. Then what we are suggesting, the common information support systems such as HR, materials, stores, finance, they can be, or the ERP, what are the main ingredients, can be done at a later stage. Then we don't have to do the IT altogether. We should have a modular approach which can be implemented depending upon the budget available, the resources available, on modular basis, on add-on basis, rather than going all together at one single instance itself. That is from concept right up to the full automation. No, we can go on a modular system. Now, the objective of integrated approaches, we already talked about improved profits, improved operational efficiencies, proper information for decision support systems, and improved customer service. Now, what should be the strategy that we need to adopt for this? We should have a holistic, structured approach for deployment of IT. We should have cost-effective and appropriate solutions. Enterprise application integration and single data point entry for all the processes. That is, data one center should be available. I should not have any access to it, or even I should not be in a position to edit it until unless proper justification is available. Top management commitment. Business process engineering as a long-term solution to go together. Preparing employees for IT adoption, employees training, and step-by-step implementation. So this slide, integrated IT adoption strategy, the first session that I have talked about is encompassed in this single slide, so that you can just be brushed what we have to do, what type of integrated IT approach we should have. Now we have four major components in IT enablement: hardware, network, software, and application packages. This is a typical layout of integrated solution, which many of you would be aware. That is, we have the back-end servers at the bottom, then we have the firewalls, then we have the different onto your right is the computer terminals, then VPN, that is from the internet also somebody can approach as the customer. This is a typical layout for a IT enabled solution. I am not discussing hardware structure. Basically it should be modular, scalable, expandable. It should be the latest industry standards with data storage at central server, data backup and archiving facility. Network architecture, we are saying it should be through LAN, WAN, and which should have a upgradable bandwidth provision, so that depending upon the traffic at a later stage we can enhance the bandwidth. Now, while having any IT enablement, software is a most important component, because hardware is only a hardware that supports the software, but the software itself is the most expensive and voluminous component, where a lot of man hours and the effort is required. For that we are saying software should be modular, it should be scalable, it should be expandable. That is, it should theoretically consider from up to infinity number of the customers. Theoretically, I am not saying practically, that it should be as per the requirement. It should not become, my system should not collapse in case the data handled by the system increases manifold. Then the software should be vendor independent, it should be technology neutral. This is the most important. What happens when the vendor comes to it, he gives his own customized solution for which the protocol or the source code is available. Anytime when we have to upgrade or make a change, then we have to go back to the same fellow and pay through our nose. Then it should be open general compliant, OGC compliant. That means if any software which is OGC compliant, the other vendors will be able to handle. It should be permitting sharing and integration at a later date. That should be the condition of our purchase order. It should be industry proven. Then multiple operating systems it should be able to handle on a database support. Then web-based application should not need any separate client softwares, and development of commercial database from existing available information base should be possible. That is, I should be able to migrate my existing database or the information data into the new software. It should have a host of security features which, while using the internet, most of us are aware that is only authentic. The people who should have the information should have. It should have appropriate firewalls so that nobody can break up into my confidential database, and it should be able to tamper with. So these are some of the security features that I tried to cover. Since the time what I find, the number of slides are more, so I'm just try to speed up so that Mr. Rudra I can hand over earlier, because the GIS is one of the most important base that he should take it up. Now, along with the IT, in the morning I talked I must do the business process engineering, the change management, and create an appropriate atmosphere. Now, in the change management and a restructured organization, one of the most essential is empowering each of the employees to take necessary administrative measures in his business process operations, including reduction of the losses. And my IT roadmap should cover these 6 essential things, that is the IT, communication network, IT security, now disaster management and business continuity, automation and business process re-engineering. What should be my organization plan? When I look at the IT, I must do the business process engineering, change management, and realigning responsibilities and authority. Now, to give you an example, a very small example which you deal in the field is, when I have got a AMR meeting, AMR meter reading, that is, I am able to automatically read the meter of a consumer. Earlier my practice was, for all my H3 consumers, generally the utilities has been sending 2 people to take the reading at the industrial premises for the consumer. If I have a AMR, still we find the utilities continue to send the 2 persons to take the reading, and based on that reading only the bills are being generated. If I have IT enabled and I am confident of my AMR, after 1 or 2 preliminary readings, I must start depending upon the AMR, then only I can start relying and feel the benefit of the technology. And this top management commitment should be available, capacities of the organization and the individuals to be built in a systematic manner along with its competencies. Change management, also business process and engineering, I have talked about it. I have got some of the slides, I will just go through it. Then leadership, I have elaborated. Then top management commitment. By top management commitment, we say, since human by nature is looking at is comfortable, is averse to the changes. So any change needs additional effort to make it acceptable. Proper dissemination of information with clearly defined objectives and benefits to be communicated to all across and all the stakeholders. Wherever it has been found IT has succeeded, the same possible only with the commitment of the top management and involvement of all, that is banking and telecommunications. Now, what is the competency building? What we are of the opinion, IT alone cannot improve the distribution of the business process until unless there is an emphasis shall be on building competencies and skills as well as shaping the mindsets. Processes, business processes have to shift to the world-class business processes, and people to be reskilled not only for initiating but for sustaining the transition process of this IT enablement. Now, what the customer expects out of the IT? He wants, the very first thing is, he wants reliable electricity, he wants prior notice of load shedding and correct information, easy fault reporting system, quick and effective fault resolution and feedback, error-free billing, easy and convenient payment options, consumer-friendly and fair addressable system, and all above he wants at the least cost, at the lowest cost the consumer is looking. What the utility expects of the IT? Higher revenue realization through seamless revenue cycle management, enterprise-wide integration of processes and single point data handling, single consolidated consumer records, superior collaborative communications and transaction management, faster, less expensive implementation and maintenance, and knowledge management and analysis. Before coming to the part below, I'll request Mr. Rudra to take over the GIS portion, because what we need today, most of you are in the process of this geographical database to be built up.
Good morning. GIS is collection of computer hardware, software and geographic data for capturing, managing, analyzing and displaying all forms of geographically referenced information. GIS is basically a combination of software, data, applications, hardware and people. When we talk about GIS, GIS is basically geography linked with a database. With a geographical information system, GIS, you can link information attributes to location, data such as people to addresses, building to streets, customer to network, asset to network. We can then layer that information to give a better understanding of how it all works together. We choose layers to combine based on what question you need to answer.
Yes. Delhi, please speak.
R.K. Dhiman.
Yeah, बोलिए.
Speaking from PCI Bithampura, Delhi.
जी. जी.
My question is, we were talking about IT application in billing areas. For IT application in billing areas, we required electronic meters in each house, but steps are being taken for the convincing of the consumer that your electronic meter will record accurate reading and there will not be any controversy on the electronic meter installation. Thank you.
Now, electronic meters, as you all have been using, I'll say for the last 4 to 5 years, each of the utility has its own experience. Now, calibration is the first thing. if we are able to assure to the consumer that we have a calibrated product and we are rightly recording the thing, neither we are less charging nor overcharging, and it's a win-win situation for this, certainly electronic meter will be of a help to him. We have to also tell him that these are the meters, earlier meters, the electronic meter, the electromechanical meters, they have already outlived its life, which had entered into the problematic areas. Presumably earlier in time we have not replaced it, so the differential billing what we are facing is on account of it. Secondly, you say there you have to also tell him that there has been certain inherent problems into it, so electronic meters as such do not have any problem at all. So another things you have to also tell him and also give him the benefit of the technology. If you have electronic meter and if you have using a downloadable type of a meter, if immediately you put it the information and he has access to the web and track his previous past consumptions itself, and this is the technology which is going to help him, he will be with you. You have to explain what are the plus. It is not only providing the meter, the other support things you have to provide to the consumer. Certainly he will help, he will appreciate your efforts.
Sir, I have to also add 2 points in this, that electronic meters basically our old conventional electromechanical meters were not measuring the low consumption state. For example, if TV is on but it is switched off from remote, the conventional meters, electromechanical meters will not measure anything.
Means
But
gadgets puts on the standby mode.
Standby mode will not
consume
measure
some electricity.
some little amount of energy. It will be measured by the electronic meter,
Yeah.
not by the conventional electromechanical meters. Secondly, electronic meter, if the wiring is not correct of the consumer, will also pose some problem. Especially earth connection, if it is not proper, neutral connection, if it is not proper, electronic meter may measure more.
Yeah, there were some problems reported in Delhi that where that common neutral was there.
Common neutral is there.
Because of that common neutral, there was some problems and there was hue and cry at that
So
time.
consumer has to get his wiring corrected.
Yeah, so these are some of the facts because of which the consumers are really afraid of. And if these things are taken care, then I think there is no problem in the electronic meters.
There is absolutely no problem.
Electronic meters, there is absolutely no problem. To make the thing simple, you can also put a 0 watt valve and say that practically nothing is 0 watt.
Yeah.
There is some electricity into it. 0 watt is not being read by the meter, recorded by it. So these are the kind, whereas the electronic meters are more sensitive. But however, you have to give him a value added product for his better acceptability.
Yes, of course. So
Should we come back to
Mr.
GIS back?
Yeah.
Yes, Mr.
A GIS is 3 views of GIS. GIS has a 3 component basically. GIS is associated with map. A map, however, is only one way you can work with geographic data in GIS. The GIS can provide a great deal more problem solving capabilities than using a simple mapping program or adding a data to an outlying mapping tool. GIS along with the map, a complete database is associated with this. This database we call it is a geo database. This database is having information of all the attributes what you require to add in GIS. This database basically the consumer ledger. If we can talk about the consumer ledger is also a database. Same consumer ledger is attached in GIS, but with the more attributes of a consumer, and this is in turn is again attached to a map. A GIS is a set of intelligent map and other views that show features and feature relations on the Earth's surface. This is a map. This is a map of USA. And the features are associated with. Features are not visible here actually. We get data from all the sources. These are the maps. We get data of the consumers on this map. For GIS, we first take a digitized and or scanned maps. Database we create through a GPS system. GPS or DGPS system. We basically go to the each consumer point, all asset points, map this and incorporate this in GIS. For example, this is a USA map. These are 5 separate maps. These are rivers. These are roads. These are states. These are capitals and these are lakes. If we put all this on one map, these 5 data layers and alike features. The most important part of GIS is asking any question. We can interact with the map, we can get the required information only on the map. For example, if we have a GIS based consumer map, then we can get information of only the commercial. If we want to know about the commercial consumers, the map will give me the GIS application and the map will give me only the location of commercial customers. Or if we want to know the location of industrial customers, we can get only the information about the industrial customers or their consumption of the industrial customers, the consumers who have not paid the bills. If we want to know the consumers who have not paid the bills, that information also we can get directly on the GIS on a map view.
The other important I'll add it here is the connectivity in the nodal diagrams itself. If a consumer is not getting the power supply, we can simply trace it down. And we can get it how he has been connected, which distribution transformer, what is the number to which line, how the supply is being fed over there, what could be which are the other network elements which are in his systems. And if we have a GIS asset also into it, I will be also, if there is a problem into the assets, the system comes, the information automatically picks up, my server analyzes it, and then this is the issue which throws back. You can continue.
The GIS is a set of information transformation tools that derive new geographic data sets from existing data sets. This processing function take information from existing data set, apply analytic function and write results into new derived data sets. This is actually map of US Shuttle Columbia. When it has crashed on re-entry, that debris has fallen over the East Texas. By the use of GIS and GIS map, GIS software, they have analyzed where the debris, the possible location of the debris fall. Similarly, by using GIS, when there is an oil spill, we can find out where depending on the other parameters, such as the flow of the sea and all this, we can find out where the oil spill will go. These are the benefits of GIS. We can skip this. This is basically how I have tried to describe how the maps are created. Because Earth is three-dimensional. We are staying in a three-dimensional plane. But whenever we are going to make a map, these maps are in the 2-dimension. Moreover, normally we can consider Earth as a sphere. This is Earth and Earth as a sphere. But Earth is actually not sphere. Earth is like a ellipsoid. The top 2 portions are little down, flattened at the pole, and for the geographical information system, Earth is basically like this. This is called a geoid. Because Earth, this is the actually mean sea level of the Earth. If we can extend this water to the entire Earth surface, this Earth will take this shape due to uneven distribution of mass inside the Earth. This is the mean sea level of the Earth. And for all geographical information system, this level as a taken as a standard reference level of 0 in all the places. This shape of the earth is called geoid. And everywhere this is taken as a reference for any height reference in the map. This mean sea level is considered. We measure the mean sea level for a period of time, and the average mean sea level is considered for making earth measurement of height. And for the measurement of location, basically map is a projection, is a mathematical projection of our three-dimensional object into a two-dimensional. For that we consider basically the shape of a earth. This we can't show it. No?
Please show the slide.
No,
show the
but
slide.
But do you have a pointer?
Pointer.
No,
उधर दिखेगा नहीं.
You can take that pointer of this
Mouse.
mouse. Yeah, mouse pointer.
For North America, this ellipse is the best. For African countries, this is the ellipse which is the best considered. For India, we take a ellipse which is called, these ellipses are called datum. These are the reference point for a map. For India, we take a Everest datum map, which is the best for India. But the GPS satellite uses the universal datum map WGS84. For India, the best map is Everest datum map. So we have to convert this WGS84 map to the Indian map condition, Everest datum map, for getting best. And the projection what we use is called UTM84, where this world is considered in a 60 zone. We take each zone and map it to our requirement map. Two important components of utility GIS implementation. One is data, land-based and electrical network data, and second is the software requirement for capturing, data porting and application development. Data in GIS data is mainly divided in following three parts. First is land-based, that is building, roads, water features, etc. Second is electrical data, that is transformer, lines, assets. Third is consumer. Data modeling is one of the most important activities for creation of good quality maps. Some of the points which should be taken care while designing data model are the attributes of the data. We should finalize what are the attributes we have to take. For example, for a consumer, we have to take all the attributes: his house address, his load demand, everything we have to take as a data attribute. Similarly, for the attributes of my equipments, for example, for a distribution transformer, we should have to take all the attributes of the load of the distribution transformer, capacity of the distribution transformer, its make of the distribution transformer, its date of installation of the distribution transformer. These all informations we have to, and all other technical features. For example, the vector diagram of the transformer. Every important features of a asset has to be taken in the attributes field. These attributes to be used for technical analysis, that is load flow analysis. Attributes to be used for planning and to take management decisions. Attributes to be used for integration of GIS with other software like SAP and SCADA. How we prepare a digital map? Compilation of formalities for procurement of satellite imageries. We have to procure the satellite imagery, and satellite imagery also which are normally available in the free domain. As per the map policy of India, the satellite imageries, some of the satellite imageries are available for public common use, some satellite imageries are not available for common use. We can procure satellite imagery from NRSA, or we can procure satellite imagery for ICONOS. collection of other documents, data from the authorities, collection of existing map and topo sheets, providing control of selected places for georeferencing of satellite imagery. The georeferencing of satellite imagery according to the desired projection system, datum by registration, translation, etc. This enhancement of digital interpretation of satellite imagery using modern software for generation of vector maps, insertion of topology from existing maps, preparation of hard copies of ground verification of maps, etc. Then after getting the satellite imagery map, we have to carry out the ground survey. Ground survey is normally carried out by using total station. Total station is an optical instrument used in modern surveying. It is a combination of electronic theodolite and electronic distance measuring device, and the software running from external in an external computer. This surveyed data through a total station after ground survey is directly taken to a hard disk and converted into map. This is a map generated through a total station survey. While doing land-based survey, this will cover everything: properties with type of boundaries, water features, public buildings, hospitals, educational institutes, industries, postal and airline information, banks, hotels, guest houses, all these things, bus route, tourist information centers, taxi stands, all this information we have to cover while doing the land-based survey. Then we have to go for the asset and consumer mapping and indexing. Existing data acquisition. We have to collect the existing data from the utility, whatever they are having in their laser and all these things, the SLDs, whatever available we have to collect. Then collection and then update the consumer data. Then you have to go to each consumer and collect the information from the consumer, collecting the attributes of the consumers. Then we have to finalize codification logic for uniquely identifying each entity, symbol definition, then critical network connectivity detail. Electrical network location survey with spatial data, collection of attributes. While doing this survey, we are taking help of DGPS. We are to going to each consumer or each asset and locating his attribute, his geographical location through a DGPS instrument, so that we can collect the geographical information of all the assets and the consumer. Along with that, we are taking all the attributes of the consumers. These informations are converted in a database which are put on a map on a GIS system. Then we have to identify all substations, HT feeders and transformer connected to it. Coding designed and forms prepared as per data model. Surveying each feeder for asset collection and electrical route survey from substation to termination. Then SLDs are prepared. Similarly for LT lines also same things are done. Picking up of asset, route survey, auto checking of SLD for coding in office and digitization. Door-to-door attribute survey of consumers. Then we have to check the connectivity, which is the most important, that connectivity of all consumer to a particular asset. Most of the time for LT consumers it is a DT. My DT is connected to the consumer. This electrical network is superimposed on a map and then geocoded. We recommend the map resolution and scale for GIS implementation that urban cities and metros scale should be 1:1000. For semi-urban the scale should be 1:2500, and for rural area 1:5000 scale maps. Basically maps are different size of maps are recommended because the maps of 1:1000 scale is very costly. 1:2500 is less costlier, and 1:5000 is much less costly. So for the commercial consideration, different scale of map are recommended for different area. And for the rural area, we are recommending that only HT and LT line survey should be carried out. There is no need to go for each consumer survey with a DGPS instrument. And map resolution, spatial resolution of map should be 2.5 meter per pixel for urban area. For pixel, basically 1 pixel means it's a, in a computer it is a lowest identifiable point. So for a 2.5 pixel map, it is the two objects with a distance of 2.5 meter can be identified. And for the rural area, the 10 meter per pixel map is resolution, with a resolution map is recommended. After making the map, the map after ground survey and map of the satellite imagery, these are to be matched. These are to be georeferenced. Georeference means if I get a map, I can show you a geographical GIS map. I will show you later. That geographical map and the satellite imagery map and the surveyed map, this should be georeferenced considering a common point. Some of the prominent landmarks, we have to match those two. The satellite imagery map, the prominent landmarks in the satellite imagery map and the prominent landmarks we have got from the survey map. These are to be matched. Then this is called georeferencing. After georeferencing of two maps, survey maps and the satellite maps, then we go for a conversion of this map in a digitized format. This is a conversion of these maps, whatever we are getting from the satellite imagery, it is basically a raster map. This raster map is basically image. These are a raster map. These are to be converted to a vector map so that it can be seamlessly, it can be zoomed in and zoomed out. This is a sample land-based data map for electrical utilities. We have to, while digitation, we have to make different quality control checks, that is dimensional accuracy, completeness, displacement, edge mapping and positioning, symbology, layering, proper display, checking and undershooting, overshooting, silver polygons. Means while doing the map, we can see that there are some in the, after digitization we may found that one road is hanging. This road has not matched with the other road. This correction all we have to do while doing this digitization. These are the use of GIS. Job design. With the GIS we can design my network planning, job designing, estimating. It is becoming very easy for us to estimate, because in that, while estimating from a point to point, we get the exact distance, how many poles are required, how many cables are required. This we can easily find out from the GIS map while doing the job. This job designing is different, is become easier if I have a GIS map. Integration with the work management, integration with the customer information. Customer information, what Mr. Dhup was earlier told, that customer informations I can get from the, if I put some information of a customer, we get the total information of the customer. So if I put the customer location, address, then we can, through a GIS system, we can easily identify where the customer is. Physical location of the customer, geographical location of the customer, and his all attributes, starting from his connected load, his date of connection, every attributes of a customer will be available in the GIS system. Integration with the outage management. We can see the network, electrical network. We can find out what are the point of breakdown. Who are the customer who will be affected with this outage. If I found a 11 kV line is under fault, then how many customers are in that 11 kV feeder, and those customers will be affected, we can easily get that information. Integration with the planning and engineering, field information, web-based connection, outage visualization. underground utility protection, job work routing, vegetation management. Means if there is a vegetation overhead line and if some trees are growing up, how many trees are there in the route where we have to control that vegetation, that also we can find out from the GIS. Lightning strike data and information, meter reading route management, corporate building and land management, vehicle location tracking. This commercially provides geographical location as well as zone and district information of existing and future customers. Total number of customers with the premises instantly. If I have a multi-storied building, in that multi-storied building, how many customers are there, that we can immediately find out. Areas of premises to find out approximate area quickly. Provide the status of premises, that is domestic, commercial, industry, etc. Provides proper address and floor information, because sometime it is hide or missed out properly, purposely or by mistake. If it is a market, exactly how many customers are there, what are the information of the customers, it can easily be found out. It can be integrated with the trouble call center. That abbreviate number 1912, which has been booked for the electrical utilities customer care center, which will be connected with the multiple line interactive voice response system to ensure the calls are priority. This trouble call center can be connected. In trouble call center, what was Mr. Dhoop was earlier telling, that the reverse tracing of customer. If I get a complaint from a particular customer, group of customer, if I get a complaint from 3 or 4 customers, and if all these 3 and 4 customers are connected to a DT, we can reverse trace and we can consider that DT is at fault. If I get a 4 call from 4 different DTs, but on a same 11 kV feeder, we can consider that this 11 kV feeder may be at fault. This is called reverse tracing of the fault. This is only possible if I am having a GIS system mapped group customer, because once I have a GIS system, all these customers are grouped, either grouped through a DT or grouped through a feeder. We can have a system planning and analysis. We can have this along with the GIS. We can use this network planning software. That network planning software will take information from my GIS based system, and this network planning software can find out do network analysis, can considering future growth and optimize this. These are the 6-7 softwares available for network analysis. The SIMDIS, Synit, Calpos, Windmill, Neplan, Hitachi Power and PowerNet Global. This network analysis tools can collect information, take the data from GIS, and they can use their computerized analysis tool. The SIMDIS primary distribution system analysis tool, this has a capability of balanced or unbalanced or 3-phase analysis of the system, 2-phase or single-phase system, all above with radial, looped and meshed configuration. This can calculate voltage drop, power flow analysis. This can do fault calculation, optimal capacitor placement and sizing, load balancing, land allocation and estimate, switching and optimization, and reliability analysis. Earlier, without GIS, if we purchase a SIMDIS, then we have to put all this information one by one in the SIMDIS to analyze. We have to do this network survey, route map, we have to put in a SIMDIS. But if I have purchased I have made a GIS based database, then this SIMDIS can take all this information, data from the GIS software, and it can analyze. And my GIS database is a live database. Basically, if we add on a line, this GIS database will capture that information also. We have to make a system like that. This GIS database will capture all the additionalities in the system. So my GIS database is always live. So network analysis, if we integrate with the GIS, then the GIS database and the network database is always a live database. The SIMDIS requirement is very simple. We can show you. This is a network analysis on a GIS based system. We can see this green line is a customer voltage above 90%. These blue lines are where the voltages are 80 to 90%, and red lines are where the voltage is less than 80%. By using this, we can always plan my design network. I can upgrade my network for improving this voltage condition of the low voltage condition. I can identify, along with the voltage, I can also calculate how much technical loss is being taken place in the feeder wise, losses for taking units billed and billing system automatically. I can find out the technical loss of the system. I can integrate the GIS with the billing system to find out the total loss. Then I can find out in a feeder how much is my technical loss and how much is my non-technical losses, which are I can tell is the commercial losses, which are the revenue losses. By doing this, I can very easily do the energy audit of a system. When I know how much is my energy input, how much is my technical loss in a feeder, and how much is the total energy billed in that feeder, the gap is my commercial loss. So I can do this energy audit very easily. I can do by doing this particular customer category wise audit. For example, if I go for a hotels, I can do the audit for the all hotels, how much is my energy audit. Replacement of conductor, for doing this technical analysis, I can replace the change the conductor to improve the system. Once we do the GIS mapping, we get the information of all the assets. So I can do the asset management, we can do the periodical maintenance, monitor outage and performance, give all details about consumer and their loads, enable scientific approach for better asset utilization and reduced outages. This GIS map, once created by any utility, it can be integrated with the all other facilities in that area. For example, if I create a GIS map for a electrical utility, the telephone utility also can put their information in that same GIS map. Municipalities, storage line, all this information can be put on a same map. Basically, GIS is a map, and over that on a tracing paper, everybody will put their information. So one GIS system can cater all other informations, and basically on a map putting a number of tracing paper, and you can use the tracing paper whatever you require on the map. The application of GIS is limited only by the imagination of those who use it. GIS is a platform to hone your exploratory and creative talent. Sir, we can.
Mr. Rudra has just told you about the GIS, its requirement and the benefits that you can derive out of the GIS. Now I'll come back to the main presentation again on the IT and the distribution. So it's just broken into the second part itself. that is the commercial management of distribution business and use of IT as an integrated solution. Now, what is the current scenario of present metering and billing collection scenario? How we have been operating the utilities? If you look at it, it's like this. I have electromechanical meters, then I have a metering, billing and collection systems, which is a manual process. Then after reading it, I raise the invoices, give to the customer, and he makes a payment. And one is either makes a payment, the other alternate he comes with a query and a grievance. And the query and grievances are always handled by the subdivision office, and subdivision offices pass it to the again to the metering, billing and collection department. So what in the sense is, he is not able to decide himself, it goes back and the consumer faces the harassment. And the information that he provides to the management is based on the manual reports, which contains clerical, willful, non-willful, both types of mistakes are there. Now, how do we with the IT enhancement? Focus areas for the enhancement of the revenue maximization. So, what I have been talking in the first session so far has been the customer enrollment, creating a database. If I have a database, everything, including the contractual positions, I can put it to the settlement, that is for the input energy verification, reconciliation and theft control, that I explained how it can be done by the help of the meters and with a proper database. Now in the metering, I have got different types of the problems. The meter data I acquire it, there are unbilled also meters, there are frauds also, there are reconciliations, assessment estimations, and I have for all categories of the metering for the residential, commercial and industrial. Then it comes to the billing, then recovery collections. This all I can concentrate activity wise through my IT enabled, and I can focus on this. Since you are from the field, you know which are the points where the revenue is being bled or the energy without being paid is being bled, so I will not talk about it. All the leakage points that has been depicted in this slide. Causes of the revenue leakages also, you are well aware of it. Now what are the limitations of the existing metering system? Presently my metering status is, I don't have meters and majority of the utilities at the agriculture. I have got faulty meters. I even don't know that my meters are faulty at the consumer end. CT ratio errors are there because of non-compatible CTs at times or the wrong ratios being put over there. Meter reading errors due to manual system of the reading, that human errors which are occurring into it. Now on the top of it, I don't have any mechanism for monitoring and accounting of energy. I am not maintaining any energy balance at each of the transaction points. So these all issues lead us to the revenue loss. What my metering model will do? See, in the IT enabled environment, it enables to help accurate metering and tapping revenue loss through exception generations. That is, in my reporting MIS system, I can know how many consumers who have not paid the previous bills itself, or who are not consistently paying, who are consistently defaulting into. Then it enables me to interface with the automatic online, offline meter reading devices. Then it captures the meter reading data from meter reading handbook, handheld computers and common meter reading instruments for uploading and downloading the data. System should be capable of upload and downloaded data for a given set of group of consumers. I can control it. Then the system also generates meter reading schedules, that is including the route map. If I have a GS based, what Mr. Rudra has expressed, I can read maximum number of meters, or I can plan the route so that without a wastage of time I can reading the meters, number one. Secondly, I am also able to control that the distribution transformer meter reading on the same day with a set of consumers which are hooked to this distribution transformers are read, so that I get a proper energy balance. And the system otherwise will also help enable me to generate alerts and the exception reports. In the IT enabled, it automatically cross-checks the data validation to minimize the data entry points, and it will have a comprehensive logic system to support and cause an alert that I have to recheck it for any of the errors. System will automatically also generate the schedule or the work order for checking replacement if the meter reading has been found out not acceptable. It will also capture the total meter history of its lifetime, right from the arrival in stores to write its reading, if any it has gone for recalibration, how many times it is checked, or when it is due for the replacement. See, this metering model of the software IT enabled platform will also be in a position to compare the various meter readers about its performance. Now the energy, the meter reader or the input that has been provided to him, the area which we have got, how much is the consumption being reported, and specific variation for the consumers. Current location of the meters, he can also tell. That is, he will take down the meter if it has gone for calibration, it is gone to the stores, or it's where it is lying. It shall also tell me whether the meter has been stuck, slow, or door locked, etc. The limitations of the existing billing systems are human intervention at many places in the process, leading to scope for manipulation. This is my existing system without the IT support. Billing errors and higher percentage of estimated billing. That is, meter reader actually doesn't go to the field, he generates the bill sitting in the office. So this is more prone to the errors, and I have no means to cross check it. Now electronic meters are installed at many of the customer premises, but readings are taken manually at most of the places. This also leaves the scope for the manipulation. Even if the reading is taken through MRI, that is meter reading instrument, output is printed and then data is collected, is entered manually for billing due to incompatibility of billing applications with the MRI. Then appropriate billing engine is not available to take data directly from MRI for bill calculation. So the last 2 points that I said, the whole error is, the issue is, even if I am using the meter reading instruments, I am not printing the bills based on this data, because this data I first take it on my ledger or correct it, that is again prone to human intervention. The whole object is, if I have a MRI, if I have put the data into the system, automatically it should generate and bill the print without any human interface.
Mr. Dhoop, we will continue in the next session, and we would like to have a break for 15 minutes right now, and we will assemble here at 11:30 again.
Thank you.